Hi everyone, my name is Alima Balu and today we talk about Faraday's law. Here is the table of content, the introduction, the experiment, computational model, results, interpretation, and conclusion. The purpose of this experiment is to observe the interaction between a magnet falling and a conductive tube of aluminum foil. The fundamental principles used are Faraday's law, Biot-Savart law, and Newton's law. For the result, the experimental one has a time of 1.3 seconds versus a 0.815 seconds for the theoretical. It was noticed that the aluminum foil slowed the rate of the falling magnet. So for the experiment, a tube of aluminum foil of at least 1 centimeter thickness was used. Our bar magnet was dropped through the tube and it was measured 5 times how long it took for it to fall through. It took an average of 1.3 seconds for the bar magnet to fall through the tube. The foil width was 0.01 meters, the tube length, the foil length was 0.332 meters, radius 0.023 meters, and the magnet mass was 0.0233 kilograms. For the computational model, the aluminum foil dimensions were entered as constant, and a function to calculate the magnetic field was created, and the magnetic flux also. The code calculated the current in ring, the magnetic field at each ring, the net force on the magnet, and the magnet's velocity and position. As a result, we observe the simulation of the magnet going through the foil at the left and the graph of the velocity versus time, and as a result the time was 0.815 seconds. So in this experiment it was observed that the magnet took longer to fall than in the experiment than in the computational model, which can be explained by the fact that the model wasn't taking into account air or conductivity resistance. Which color corresponds to clockwise current and which counterclockwise? Blue corresponded to counterclockwise current, whereas red was the clockwise current. When the magnet is flipped, it flips the direction of the current. And the velocity versus time graph show us that the magnetic force was constant throughout the tube. As a conclusion, the magnet would have fallen more slowly because the induced current would have been larger if the resistivity of the conductor were reduced as close as possible to zero. And if holes or slots were cut into the tube, the magnet would have fallen faster and the induced current would have been reduced. This is the end of the presentation. Thank you.